So the nuclear bomb working principle. Um, about the nuclear bomb working principle, it's from the International Atomic Energy Agency. It's the world center of cooperation in the nuclear field. It was set up in 1957 with the United Nations family. It works with its member states to promote safe, secure, and peaceful nuclear technologies. In a nuclear bomb, uranium-235 releases two neutrons when it fissions. This allows it to sustain a chain reaction. If the two uranium isotopes were to rate from New York to Los Angeles, the lighter isotope would arrive 25 feet ahead of the heavier one. A little bit of science behind the bomb. The immense destructive power of atomic weapons derives from a sudden release of energy that is produced by splitting the nuclei of the fissile elements which makes up the bomb's core, and this is what happens in the very first picture I had on my title slide. The U.S. developed two types of bombs. One was named the Little Boy and the other one was Fat Man. The Little Boy is a gun-type weapon with a uranium core, and the Fat Man is an implosion-type device with a plutonium core. Isotopes uranium-235 and plutonium-239 were selected by an atomic scientist because they readily undergo fission. Fission occurs when a neutron strikes the nucleus of either isotope, splitting the nucleus into fragments and releasing a tremendous amount of energy. Fission process becomes self-sustaining as neutrons produced by the splitting of atoms strike nearby nuclei and produce more fission, which this whole process is known as a chain reaction, and this process causes an atomic explosion. When the uranium-235 absorbs a neutron and fissions into two new atoms, this releases three new neutrons and some binding energy. Two neutrons do not continue the reaction because they are lost or absorbed by a uranium-238 atom. One neutron does collide with an atom of uranium-235, then the fissions, and this releases two neutrons and some binding energy. Both of these neutrons collide with uranium-235. Each fission and releases between 1 and 3 neutrons, and this causes a nuclear chain reaction. So, an example, in order to make an atomic weapon, you need a critical mass of fissionable material. This means that you need enough uranium-235 or plutonium-239 to ensure that neutrons released by fission will strike another nucleus. Like I said earlier, this causes a chain reaction. The more fissionable material you have, the greater the odds that a chain reaction event will occur and it will cause an explosion. Critical mass is defined as the amount of material at which a neutron produced by a fission process will, on average, create another fission event, which is not usually a good case. The working principle, if a large nucleus breaks down to give smaller nuclei, this process is termed as fission. Atom bombs are generally fission bombs. They use uranium as fuel, which breaks down to release a lot of energy. The breaking down of uranium nucleus is initiated by a single slow-moving neutron, and then this continues as a chain reaction. This happens because each fission releases 3 more neutrons. This releases a lot of energy, which is used by atom bombs for creating destructive effects. When two small nuclei fuse to form one big nucleus, it is termed as fusion. Even fusion bombs have been created. Their testings are not very easy since they can cause more destruction. A little bit more like definition-wise of the working principle. The working principle is a rule that is adequate to permit work to be done, and it's a principle or condition that customarily governs a certain behavior, like the chain reaction that causes the nuclear explosions.